Hi everyone. Today we're looking at multiplicative inverse for matrices. So I'll go into, the basic idea behind it, and then I'll do an example. So hopefully this is beneficial to you all. So as part of the Year 11 general course, you'll only ever be asked to do, or at least by hand, an inverse of a 2 by 2 matrix. All right. Okay. This is the matrix here, and what I'm going to do is in blue, right next to it, I'm going to do an example. You can follow along with, let's say, 3, -4, -1, and 2. All right. So if this is my matrix and I want to find the inverse, and I should let me go back a stage as well. So this is our matrix A. The reason that we would do something like this is, let's say we have A times B equals some matrix, let's call it C, and we want to find out what this matrix B is. Normally in algebra you would divide both sides by A, and you would do it that way. But unfortunately in matrices you can't divide by a matrix. You get some tricky errors that come up with it. So the alternative to that is, if you have A times B equals C and you want to find out what B is you multiply A and B by A to the power of -1, right? Which means you have to multiply C by A to the power of -1. And what this does is it's essentially the same as dividing, because if you know your index laws, A to the power of -1 is exactly the same as 1 over A, right? And if it's 1 over A times 1 over A cancels each other out in the same way that dividing does. So what we're trying to do is we're trying to find that A -1, which is called the inverse. So to do that, we have this formula here. So I'm taking this original equation at the top. We're going to have 1 divided by AD minus BC. And I'm going to swap these around a little bit. So A and D are going to swap places. And B and C are going to stay exactly where they are, but they're going to change powers. All right. So if they're a positive, they become a negative. If they're a negative, they become a positive. So we'll jump over here and I'll do the example now in blue. So we have 1 divided by, so A times D is 3 times 2 minus B times C is -4 times -1. All right. And then we have our matrix. So we swap these values around. So 2 and 3 swap places. And these two change powers. They change signs. So -4 becomes +4. -1 becomes +1. Okay. So I'm just going to solve this at the bottom here. So 1 over 6 minus 4. So this becomes 1 over 2. All right. Cool. So we have that. From here, we look at the idea of scalar multiplication, which I should have covered in the operations video, but I can do a separate video if you'd like, where we multiply the scaling number outside by all the values inside. Right. Now, this is going back to one of the first videos that I made where I talked about different types of matrices. If you get to this point and you end up with, say, a number minus another number and the answer becomes 0, because you can't do 1 divided by 0, this means that there is no possible inverse. So if you can't find an inverse, that's called a singular matrix, which again I talked about in the very first video. But if you got to this point and this bottom value isn't 0, it means there is an answer. So what we're going to do is let's solve this. So we're going to times everything in here by this, or 0.5, whatever you think is easier. So a half times 2 A half times 2 is just 1, so a half of 2. 1. A half of 4 is 2. A half times 1 is a half. And 1/2 times 3 gives me 3 over 2. So that's my inverse value. And what this means is if I were to multiply this original equation up here by this, my answer would be 1, or the matrix equivalent to 1, which is the identity matrix. All right. So this is our inverse here. That's, I guess, the basic example. Hopefully that helped. I might do some more challenging examples if I get some more time to do it. But thank you for watching the video. I hope you got something from it. Enjoy your day. That didn't work.